We are live today to talk about cloud journey for all the projects under the Key umbrella. Alex, hello, as usual, how are you doing?
I'm doing great, and I'm really excited going through this journey. We just have the last session about Kogito. That's like where we are landing the cloud, but it's going to be great to hear where we came from and now this story on key and business automation on cloud.
Yeah, indeed. And today we are not going to show you how you can deploy your applications, but actually we are going to tell you how we could enable our applications to run on cloud environments, containerized environments, hybrid cloud, and more. So we will talk about the challenges, what what did we do to handle, like, for example, persistence within containerized environments, and more. Alex, who do we have today?
Today we have one great engineer, the part of the team that is ahead of our cloud team. He's one of the guys that's responsible for creating all these images, all the setup, working on operators, and all these things that he give us some good insights about. So come here, Filipe Spolti.
Hey,
Welcome to stage,
Spolti. Yeah,
thank you for accepting our invite to be here today with us.
Yeah, of course. Thank you guys for having me today. It's a pleasure, as always, talk about key products.
You are working with the products for a long time now, right? You joined almost at the beginning of the containerization story.
Oh, yeah. Well, everything had started a few years ago with the XPAS initiative, which stands for Red Hat Platform as a Services. If my memory is not failing, it was somewhere at the end of 2015. And the major purpose of this initiative was to provide the Red Hat middleware on OpenShift to introduce a new way of building, deploying, and enterprise applications. We can say also that one of the most excitement was behind this all was the high number of companies and images that start to appear in the enterprise landscape, right? So Red Hat could not be outside this big wave that was coming. So on the
and to add to that, Felipe, and Red Hat was leading this space, right? We jump in right as a Red Hat as a company. We're jumping in Kubernetes world. We're shifting to OpenShift and 3. Everything was. I see your shirt. I know that I recognize containerization. Yeah. So that's a lot about where we came from, like in the early days. So exactly. We jump in really early days, and I don't have exactly the data, but I recall that if you are not the first, we are one of the first business automation tools out there in the market to be containerized and running in cloud.
Yes, that's correct. In fact, the 3 of the first offerings that Red Hat XPAS initiative delivered to customers was 3 products, which was the Jboss Fuse, Jboss BMS that it was have today as decision manager, and the last one, the data grid.
Data grid. Yeah. I see. So BRMS is Red Hat Decision Manager, which is the product version of the project Druze. Hey, Statis, how are you doing? I like to talk to you guys, right? And girls on the chat at home. So feel free to send your hi on the chat. We love that chatty going on over there. So, and feel free to share your questions too, because today it's your time to talk to Spolti. Spolti, we'll take it easy on you, okay? So BRMS is related to Red Hat Decision Manager. So it used to be on version 6. Decision Manager is on version 7, and it's about Druze and Optiplanner. So what about the others, Data Grid and Fuse? Because we never talked about this before on the KieLive. So just give us a little brief on that.
Yeah, the Jboss Fuse is all about integrate things. With Jboss Fuse, we can connect different applications talking different protocols, and you can also integrate data coming from the various sources we have today, like JMS, REST API, etc. As well, it can integrate easily with any kind of API published somewhere. In the Jboss data grid, for the community people, it is known as the infinite span. It is a NoSQL and distributed data store that help to boost the application performance, right?
Yeah, and it is key because on Kogito, and we will talk about this in a while, but Kogito actually uses data grid. So let's hold that thought. Hold that thought, okay? And so I imagine that you were telling us like the really early days on how we started the cloud journey. And I imagine that the teams were not ready for that. Did we have to restructure the internal teams in order to like deal with these new challenges for the cloud journey?
Yes, exactly. Well, if I recall correctly, a new team called Cloud Enablement was created in 2015, I guess. And well, we need to have focused people to only drive these efforts and deliver what Red Hat was proposing, right? So yeah, we had an entire team totally dedicated to this effort, and I had the honor to join this team on January of 2016. And at that point, the cloud enablement team already was on an advanced stage, and most of the middle product that was offering on that time was already available on the OpenShift. Like the Jboss BPMS, which stands today on the 7th version of the Red Hat Business Automation, Process Automation, sorry. As well, we had the Jboss Web Server, which is formerly known in the community by the Tomcat. Jboss AP itself, as Jboss AP is the base image for almost all of the images we deliver today. It was the main one and the most important at this point. And also we have the Red Hat AMQ, which is the Red Hat implementation of the community active MQ messaging service from Apache. Yeah.
And that's interesting, Filipe, sorry to interrupt you, because that sees kind of the nature how we evolve and learn, right? Because it started as like a company product initiative to make things that our portfolio integrate and work well in the OpenShift, right? In Kubernetes world. And while in parallel, the engineers team were also understanding, learning how to get all this working together.
Yeah,
so
exactly.
And ended up like years now we have Kogito released. That's a different world, but other than the start. But back it's like a lot of learning process. And
yes, at least myself, when I joined the cloud enablement team, I was working on the Red Hat support for Jboss and BPMS and rules, and it was actually too challenging because I had to learn deeply all of the products was there that we were delivering. AMQ, Fuse, Infinite Span, BRMS, and BPMS was easier because I already know a little about it. And Jboss was the most easy to me because it was.
You even have a book about it. Come on, Mr. Humble.
In fact, I start my career managing Jboss applications. I start to manage Jboss since the version 3. It's pretty old.
Okay. Good. So with this background, which were the challenges that we have on like getting business applications in the cloud space? What does it mean? Did you only get that application and throw it into a container? That's how you did it? Like, what did it mean to to get our business automation stack and put it on the cloud, which for Red Hat is OpenShift?
Well, this is actually a good question. And to start to answer that, I would like to start with the following statement: cloud ready is not cloud native, right? In a nutshell, cloud ready, in my point of view, is about bringing something that is there running on the bare metal for a while, and we try to bring this to run on a cloud environment. So to make this happen, we have to sit down, understand all the complexities behind a cloud infrastructure, because if you are going to just get your container and put there and like pray to ThingWorks, you are mostly like fated to fail. So understand all the complexities behind this is pretty important. And yeah, on the other hand, the cloud native stands for something that was born to run on the cloud environment, right? Mostly like we have today is microservices, and is where Kogito came in, right? For the second question, I think I answered in part, but besides all those complexities we need to care about, the most important is the security. Security on the cloud is one of the most important subjects, in my opinion. Let's say that someone accidentally exposed something that can be exploited remotely by someone, right? And the damages that it can cause for the company are uncalculated.
Yeah, and that to your point, Filipe, we are releasing this business automation that drives a lot of business out there. So business process and business and decisions and business rules are running out this very confidential, very important, very deep, important data through the systems.
And it's the heart of the business, right, Alex?
Yeah.
It's the heart of it. So yeah, and another point on security is that people think that they can just grab whichever container there is there out on Docker Hub, and that's not the way to go.
Yeah.
So did we like work on our own images for EAP, all those stuff?
Before, let me add something. I don't know if you guys have heard in the past, there was a few of container images on the Docker Hub that had a binary inside that when you started to detect the container, it started to mining bitcoins on the
Oh!
Yeah.
How I didn't think about that before. Look, everyone uses Docker, so you just push an image in there and start mining with a lot of machinery.
I will not say what was the image, but I can say that this image
was popular one?
widely by the community.
A popular one. Okay.
But fortunately, that was catched up and removed from the image.
Good. So what did we have to do in order to get our product in containers, into images?
With us in the, I mean, talking about what Red Hat in this process was not different. As I told you before, but before making a container public to the customer, we had to make our homework and make sure that we would not expose and delivering exploitable containers, and as well. Besides that, we had to find a way to not perfectly tuning, but find the best way to allow customers to turn in the applications running in our containers. For that, we created a solution that can automatically calculate the JVM parameters and kind of tuned that for you based on the container limits. For example, in the OpenShift, you can set limits, right? You can set hard limits to CPU and memory, and our containers are able to read that and configure the container properly before running it.
Oh, so the tool that we use is able to understand from the Kubernetes environment, from the OpenShift environment, which is the amount of JVM maximum size that we should configure. Oh, that is interesting. Cool.
Yeah.
Interesting. And so the projects are there for a while now.
I know.
Like way before we start this cloud story, right, Alex? You're here since the very early days. So
yeah.
So I'd like to please go on.
No. Yes, exactly. And as mentioned by Filipe, all these projects that we're talking here is dating 10, 15 years in code base. So they were not cloud native. By definition, there wasn't cloud that time.
Yeah, exactly.
So, and then we move it forward and try to adapt. And I think we're doing an amazing job. But this phase, especially on this timing that Filipe mentioned, 15, 16, like there's a lot of fluidity there. So, and get all these pieces that were published, kind of what we call lift and shift, right? So we move what we have in VMs or whatever to containers.
Yeah.
But I have that challenge.
Yeah, exactly. So can you tell us a little bit about these challenges that you have during this process? Because I'm sure we have a lot of people out there who have also their applications that they need to migrate to the cloud, and telling them how Red Hat deals with it is like very good for them. So could you share a little bit of our challenges?
Yeah, sure. Well, for all of us in that team on that time, it was very hard and challenging because every step we moved forward, we found a new challenge, and we had to overcome this with intelligent solutions. So, well, in the beginning, we just having the Kubernetes getting started. I mean, the first stable version of the Kubernetes came out, I guess, October of 2014, and this cloud initiative had started in 2015. So it was very close, and in that time we did not have too much people or too much examples available out there. So we have to figure out most of the things by ourselves. And one of the most challenges that we had on that time was to define a pattern that could be used in our images that we were going to deliver, right? That was really difficult because we didn't have just one kind of image. Like not all of the images were based on Jboss AP, and we could not rely only on technologies available on Jboss AP. So to overcome that, we created a modular thing. With this modular thing, we can write different modules and reuse them when it makes sense, right? And besides that, we also had to create we tried to observe all the complexity of handle plain Docker files. I mean, when you are building small images, a Docker file is very handy. But imagine that you have a giant Docker file with a lot of different dependencies coming from different
options, because people need to configure like their applications differently too. Yeah. So I imagine that it would be huge.
Exactly. And to overcome this, we create a tool that's called today CKit. Over the years, we have improved this, and I can say also that it has another names like CCT, which stands for Container Creation Tool, but it wasn't on the very early days of this tool. So this name is kind of something historical for us. And yeah, the main purpose of this tool was, of course, get rid of the Docker files. And instead Docker files, we have just one YAML file that we call as image descriptor. The CKit will read this file and pull out every dependencies that's needed, and all the modules as well, and place in the image and build it. With CKit, we can easily assure consistency between the images, as we can have versioned modules and versioned dependencies.
Do we reuse these modules within different images on different products on Red Hat?
Yes. Until today, we have a shared module that is basically used by all the other teams.
Oh, I see.
Yeah, we have our own. The Jboss AP had our own repository as well. The InfiniSpan guys had, but we have just one common that holds, I can say, most of the important bits. And yeah, and CKit today is widely used internally by Red Hat, and I hope that community starts to use it as well.
But yeah, and again, another experience, right? We learned to get all these dependencies, because Docker, as you mentioned, everyone builds their own Docker local. This query is really handy to have that Docker file easy, but when it grows out the complexity with all the options, and we are talking about our customers that are putting these things in production, they will do all possible combinations that every place that you go, there is a different combination out there. So to have a Docker file, it wouldn't be possible. So these technology help us to create modularized way that we can compose and build this real production-based images. That's fantastic.
But this is one of the things, right? Because we still have to test that.
Of course.
We need to assure that these images are tested before delivering them. So did you just drop it to QE and take it? It's your problem. How do you deal with it? Do you have automated tests for the images?
If we could just deliver to QE, it would be awesome, right? Just kidding. Yeah, the challenge part, the test part was also very, very challenging, because we did not have available tools on that time. And again, we have to create our own tools, or help the community to improve their tools so we can use that on our products. And that was what happens. For unit tests, today, until today, we continue using that was initially used, which is the behave, but the behave was not ready for the container world. So what we did was get the behave framework and add our own framework extending behave. So in that way, we could basically do any kind of unit tests on our images. And the good side of the behave, it is written in Python, so it will be very easy to integrate with CKit. And the tests are written on a natural language. So for example, we could say when like a container is ready, check if the container log have the, I don't know, started in 10 seconds, for example.
So we have BDD for our images.
Yes, we have.
Awesome.
Very nice. But I imagine that these, I mean, we are lifting and shifting applications that existed already. So I imagine these applications are not as light as like a brand new Quarkus application and blah, blah, blah. So like, what about the image sizes there, Spolti? Because I imagine that impacted you too.
Yeah, backing a little bit, we did talk about the unit tests, right? But we forgot to mention the smoke test, where we need to assure that the container we'll get started and run the application we have deployed, right? For this, fortunately, on that time, we had the Arcadian Cube, which is part of the Arcadian framework test. They had started the cloud testing framework for middleware products, but at that time, the Arcadian Cube was not completely ready. So what our team did, we helped them to improve Arcadian Cube so we can have a end-to-end test running entirely on OpenShift, right? Get the Jboss container, deploy an application on it, and make some requests when it's get ready and available on OpenShift, right? And last, we also had the bets test. It's a kind new
bets test.
Bets like bet.
Okay.
Yeah. It's a framework for testing bash scripts. It very came handy to make basic tests when the community is helping us by sending pull requests, for example.
I see. Good.
And then regarding the base images size, what I am tempted to disappear for a little and back after we cover this topic.
Yeah. The image size is still standing one of the major problems we have today, right? As the project is evolving, getting bigger is something normal, right? As you are going to add new features, more libers are added, and etc. And but in the beginning, we found out that the Jboss cumulative patch, the famous Jboss CP patch, actually was not deleting the old artifacts. So for the most artifacts, we could have them twice or even 3 times stored on the file system, right? And the way we found to overcome this was found all those outdated jars, remove all its content, and keep only the reference for the file. So by doing this, the Jboss will not go in crazy, and it will still recognizing the updates that was applied. But today, on the recent days, with the help of CKit, we can keep track of almost every file we put inside our images, and we can safely remove what's not needed. And I don't know how exactly when, but Red Hat, I think it started on Red Hat Enterprise Linux 7. They start to deliver the minimal image that basically contains only the kernel and the dependencies that must be there to the container get running. And when it gets released, we start to use this. And nowadays we have the RHEL 8, right? And together with the RHEL 8, we get the UBI images. The good thing that they are totally free, so anyone is free to use it. And we start to use as well. The UBI minimal image is even smaller than the Red Hat 7 minimal. And yeah, that helped us to decrease a little bit, but we still have facing some sizing issues, unfortunately.
Yeah, and sorry, Karina, and remember that we brought in basically monoliths, right? That time was the architecture 6 and 7 that we're talking about here were monoliths, so they're big and
they are monoliths.
And we're heavily based on application servers. That's a different architecture. And now, but as we are here, we can about the image size, and there was a game changer, right? When we have now Quarkus on Kogito. So,
but see, Alex, a break there, right there, because the first time we improved our images was a company effort. So we had a new image for RHEL, which reduced our size. Again, we are taking benefits of another company new, which is Quarkus and native compilation. So it's not a single effort on business automation.
No.
It's the whole ecosystem, right?
Exactly.
Yeah, they say that you need a village, right? So that's exactly what we're talking about here. That's how we collective improve the work. So all these pieces are there, and we leverage, and I think that's also comes back to the historical collaboration that, especially in the cloud aspect, was bringing all together. Because when you're running things in the cloud, you want to make sure that things work well together. Is not that's one particular piece that we want to bring everything together and then improve, and then we see our problems and we try to find some solutions.
But you were talking about the game changer on the image sizes when I interrupted you.
Yeah.
So what are you going to talk about? About Quarkus image size? Was that it?
Yeah, and exactly. The Quarkus image sizes that we have today in Kogito are very different from what we have in V7, right?
Exactly. Quarkus was a game changer for the entire company, entire for media company as well. It has changed the way as the world sees Java, right?
Exactly. It's not for Red Hat, it's like for the Java ecosystem. It was a thing.
Yeah.
Please go on. I'm just like I'm interrupting every time.
No, and you see, and now beyond just the JVM optimized low memory footprint and all these advantages and developer experience, the cherry on top is too that we can create native images.
Exactly.
And that goes above and beyond what I initially expect.
Yes.
But still on PAM. Like we were talking about the journey. We were talking about the journey. And then we had all these challenges to get there. And when the user started using these images, they had to work with templates, right? So we had a couple of templates there. What is a template?
Yes, that's right. At the time that Kubernetes was first released, the Kubernetes API was not too complete as we have today. So to deploy applications, the better way we had in that time was rely on application templates. Application templates are basically a YAML or JSON files, which contains a bunch of Kubernetes objects that combined together can deploy a fully working application on the OpenShift or Kubernetes. But it has more downsides than positive things. For example, is at least for us on the development side, it is something very, very hard to maintain and keep it consistent between the releases. One way we found to help us to keep at least the templates working for every pull request we was going to send, we have created a kind of validator, which we add to our pull request checks to make sure that our changes didn't break anything, right? We had cases in the past while, for example, updating a lot of templates at the same time and forget something is totally normal. I mean, we are messing with templates, we are messing with too many different things at the same time.
And how many lines those templates, right? Thousands of lines.
At least for the business automation ones we still have today, all of them has around 1,000.
Okay.
Yeah.
So but at the time, like we were on OpenShift, we are still there are lots of customers using OpenShift 3.11, and the templates brings ready to use architecture. So there is, for example, the trial template, Autorin, HA, and some others. But what changed with the upcoming of OpenShift 4 and the popularization of the Kubernetes Operator pattern?
Yes. Well, to be honest, I would say that, but I'm not 100% sure about this. I think the business automation team was one of the first teams on the Red Hat Midway.
Notice how careful he's being on saying that. We were the first.
Well, we were one. I think we were one of the first teams that has adopted the operators framework. Well, I was not involved since the beginning of the operator development, but I can say that it was very, very challenging. And as we were embracing uncharted waters, right? Also, I can't say today how many customers are adopting operators, since we still have some customers using OpenShift 3.11. But unfortunately, our operator is not supported on OpenShift 3.11. And for customers that still want that, we still have providing the application templates, but they are deprecated, and as the deprecation pattern, we do not provide any new features on that. So,
but still provide bug fixes, correct? Not new features, but bug fixes?
Small ones, critical,
okay.
I would say.
Yeah, but there is another aspect, and then I play devil advocate.
Porcelli.
I still hear a lot of people saying that they miss the template, the flexibility to just play with the templates.
Well,
it's a hot topic every time that we talk about the operator.
Let me add something. On the very early versions of the operator, we had some customers complaining about it, and we heard them. We add on the operator a mechanism where the operator will create config maps with every kind of possible configurations you could apply to the business automation deployments. So I can't say it's 100% customizable, but you can do almost everything you want.
That's awesome. Good. That's awesome to know. There is one additional problem with operators that I'd like to hear your thoughts. Is for developers that get access to, they need to install the operator, you still need to have the cluster admin rights. I think that's the last of the problem that we're facing.
It is not a limitation of our operator. It's a limitation of the operator framework itself. So unfortunately, there's not much we can do.
So it's not a limitation of the business automation operator.
No.
It's from the pattern itself.
Yeah.
Yeah, the operator. I think this has been started in the Kubernetes. It has been discussed in the Kubernetes.
Yes, it is under discussion. It is this way because when you are going to install a operator, it has its CRDs, right? With the custom resource definitions, which exposes the operator API that will kind of listen to a a custom resource to deploy the application on OpenShift. And unfortunately, when the OpenShift does that, those CRDs are deployed cluster-wide yet. So that's why we need the admin cluster permissions to do this. But it is not that it just affects just us. It is affecting all the operators out there.
Yeah, indeed. And before moving on, I'd like to bring a question. So we were talking about CKit before, CKit, whatever. Yeah. And is there any other option to build the PAM or DM images other than using the CKit, or people have to use it when they need to rebuild the image for some reason?
Well, use the CKit is a little bit complicated because we rely on some internal infrastructure services that could not be opened. And what we was instructing customers to do is how they could extend our images using the Docker file and make the customizations they need. So today, we advise the customers to use Docker files.
Okay, I see. And we have our folks thinking that cluster admin is one of the things that is holding back the operators of getting popular. Let's see what the future holds for us. So, Alex, can you think of other challenges that they might have had during the cloud journey?
Oh, I can. Well, me and Felipe has been some meetings about that persistence. Persistence, I think it's one of, at least my perspective as the engineer on the other side that delivering the parts of the product. Dealing with persistence in the Kubernetes world is quite complex. I'd love to hear your thoughts about that, Felipe.
Yeah, indeed. It is complex and still complex until today. Yeah, the persistent volumes are yet a super important piece of our the business automation product. I mean, the containers in the cloud environment, when you just run the container as it is meant to be by design ephemeral, right? It does not save any state, nothing. So when you start this, it will lose any kind of configuration you apply. On the very beginning of the business automation journey, we didn't need persistent volumes because our offering on that time was just decision as a services. And on that time, the images were totally ephemeral. We did not save state from the rules, the rules itself. So later, as we start to evolve the container images, and as also the product has evolved as well, on the 7x version of the business automation, we added some new features. Also, like we had the key server to run business process and rules. We had the business central to altering your process and rules, and we also had I don't remember if the smart router was there at the first time, but the smart router is something you configure when you have to customize, like for example, if your environment requires to have the two versions of the same process.
Yeah.
We could configure the smart router to correctly route the request to the right process.
But Spolti, when you add a new component, you are adding extra complexity, right? So which were because it's a trade-off. So which was the trade-offs in the situation of having to deal with this persistent context in our scenario?
Exactly. The persistent volumes are not a silver bullet, right? It will not solve all the problems we had, but it solved the majority of them. So as the product was evolving, a new challenges has appeared. And for example, what would happen if we try to scale our pods up, right?
What would happen?
As we will have exactly the same pod running the same container running in two different pods, it will share exactly the same persistent volume. So the persistent volume needs to support read write many, which means that multiple sources can read or write on the file system at the same time. Unfortunately, we have out there some cloud providers that have some file system that does not support read write many operations. We can mention the AWS EBS and the Microsoft Azure. Sorry. Yeah, to overcome those issues, the core engineering together with the cloud team, we came with a few solutions. And for example, for the HI environment, which is the most complex that we have today.
And today we have HA on OpenShift, right?
Yes, but it is not the conventional high environment we see on the bare metal, right? it's a little bit different. On the business automation world, when we talk about HA, we are basically assuring that the business central components and everything in there will be replicated between all the running pods. And this includes the indexing and the CDI events. I not talked much about them because I don't know the architecture behind this. But if Bercelli, if you can add this a little bit more background on this.
Yeah, I can
I
add a
love
lot.
when this happens. I just love. I'm just here. Where is my popcorn? I need some popcorn.
Yeah, that's interesting. So again, Business Central, it was born like a monolith. So it's a Java EU standard application, CDI based, events everywhere. It's event based. What happened in later to this cloud journey? But when distribute it there is a lot of challenge, because if you create a new file here, basically it's an event. You need to distribute this event across all the pod running. The way to do that is to create a mechanism to listen to events. But as you know, Java EE standard is focused on the application server itself, not across the cluster. So we create the mechanism that we distribute the automatic CDI events. You just annotate that one CDI event, say this has to be cloud or distributed, and this will distribute this information across the cluster. That was one part of the thing, and that probably is the easiest part of the events. The hardest is what Filipe said, is the persistence of the data. That's a Git repository.
Oh my God, yes. But just one thing, these events that you're saying, I just would like to clarify, these are not Kafka events, right?
Yeah.
It's on the JVM level that you're just communicating with each other. What, like WebSockets, something like that?
Yeah, we have our bus inside.
Okay.
There is a bus in there. So just that this technology was before WebSockets.
Okay.
And we have some not the best experience with WebSockets, because we learned it in a point in time. Some proxies were cutting the WebSocket connections. So that was another thing that we faced issues. And our bus is SSE. That has been fine for a while. But back to the storage side, we have the Git repositories are stored there. And we have to avoid to have all the rights at the same time, as Filipe mentioned. Otherwise you may corrupt the Git repositories.
Yeah.
And that was really complex, because then we need this read and write infrastructure shared across the pods. So, and we create a mechanism that's quite reliable in some level. It works, but it depends on the infrastructure. And Filipe mentioned EBS and Azure. I recall being a call of a customer that was using a particular configuration on the Amazon, that it was incredible. It worked for 5 minutes and then stopped working. I said, that's not how computers work, right? So, and then after a lot of investigation, we learned that particular way to mount that particular persistent, there was a budget for performance.
Really?
So, yeah, so you have good performance you have a budget for performance. And after that, it drops dramatically. It goes from 100 megabytes per second and drops to 5 megabytes per second.
Whoa.
When it drops to 5 megabytes per second, everything's stalled. Nothing moves on, because you are waiting for the write or waiting for reads. And that stopped work effectively. But took a while to figure out that was.
I can imagine that's like cloud environments are too complex, right? Mainly when you are dealing with quotas and money.
Yeah, and that's exactly that. Because if you configure the Amazon to provide a high throughput whole time, the I/O per second, high volume all the time, it's really expensive. It's unbelievably expensive. But if you just do the default, the price is almost priceless. The cost is really low.
So we've discussed about key server, Business Central, smart routers, journey to the cloud, but we've learned from that, right? And then we apply that knowledge to the new project that is Kogito. And I wonder if, because since we learned from it, I assume that we already have an operator to help on deploying Kogito. And Kogito has lots of add-ons on the ecosystem, like Cristiano said on the last live session. If you didn't watch, take a look. He explained at least 5 components. So do I have to deploy it? How do I work with that on the cloud? Because it's now it's real cloud native distributed services. So how do I deal?
Oh yeah. By the way, great presentation that Chris did last week. Last session, sorry. Of course, the Kogito operator is out there as well, and with the operator, you can get deploy everything automatically deployed for you. We don't need to handle with
one comment. Look at how Filipe is smiling now. No, he's relieved. He's smiling. He's happy. That's great.
Oh, wait, didn't the operator also deploy everything automatically for us with PAM? It does. It just gives more work for you on the engineering team, right?
It not just only deploys, but it assures that all the components will work together.
Oh yeah, we didn't talk about it. What is the difference between a template and an operator for Kubernetes?
Right. Basically, templates, though it's not assure consistency, right? You deploy the application with the application templates. If for some reason someone deletes something by accident, it is deleted, and it can cause some headaches to revert it back, right? On the other side, with the operator, when you define a custom resource and deploys it, no matter what, the operator will assure that what is defined on the CR is actually deployed on OpenShift. So suppose you delete something accidentally, the operator will automatically identify that right away and revert the action back. So if you delete something by accident, you can get calm and just wait the operator doing his work.
But that's also a thing, for people who are not used to working with operators, sometimes the person goes there, and it happened to me on the first time I worked with it. I changed something, and then I save, and it just ignores my changes. Yeah. And then I found it out that I have to change through the operator, and then it will get it sorted out, right?
Exactly.
Perfect. So we have this with Kogito, right? Good. Yeah. Okay, I see.
This is a operator pattern, so Kogito or the business automation operator will behave on the same way.
Okay, I see. And is there anything else other than the operator for Kogito to work with cloud with cloud environments?
What do you mean?
Something for a command line.
Oh yeah, sorry. Yes, the Kogito has the CLI option. With the CLI, we can do almost everything that OC does, the OpenShift container line tool, plus some extra functionalities we add explicitly for Kogito. For example, if we are going to deploy a Kogito service that depends on Kafka, we just need to instruct the CLI that I want Kafka being installed, and the operator will handle that. The Kogito CLI together with the operator will handle that for you. The same goes for InfiniSpan for persistence.
And those are totally necessary depending on the use case we are having or the add-on that we are putting on our architecture. So we are talking about OpenShift, but what about Kubernetes upstream? Is there can people use the operator also there?
Yes, the Kogito is out there for the community, so we have to make it available for upstream Kubernetes, right? And yeah, and for the product, on the past, our main focus was making the product available, and for the community, we have created some images, but those images are just a standalone images that are not too complex that the product is. And for Kogito, we started totally different. We started from scratch and start first with the community, and everything we delivered in the community should be there for OpenShift and Kubernetes users.
Perfect. And to wrap up, there's a big change on the way we build the applications with Kogito and the way we build the applications for PAM. So could you just talk briefly about it? Do we use the two-step build for the images?
In fact, yes. We did not drop the search to image functionality altogether. We had this discussion in the past, but we figured out that we have some customers out there that likes S2I. So that's we didn't find a solid reason so far to totally remove it from Kogito. But yeah, as Alex mentioned before, when Quarkus came in, everything has changed, right? The way we are building applications on the old business automations images, we basically rely on S2I and Maven repositories. The S2I basically works by receiving a source code, a binary or something else that a user wants to copy to the image, and that depends on to have a builder image, right? And usually this builder image contains all the tools you need to build something. For example, if you are building a Java application, the Maven will start to download the internet, right? And the image output when this happens is very, very large, and we result on a very large image. So the S2I team came with a solution that we can provide the builder image and the runtime image. And we do have this for the product and the Kogito. With this runtime.
Oh, we have it for both. That is awesome.
Yeah. And this runtime image will receive only the build artifact and the needed dependencies. Everything else is just thrown away. And yet for Kogito, we have some more options where you can build everything locally with common Maven commands, Maven install, Maven package, and etc. And with the Kogito CLI, you can get those build artifacts and tell, hey, Kogito, I want to deploy this artifact, and to press enter, and it will be deployed in OpenShift for you.
So, and that CLI basically communicates to an operator, right?
Not to the operator itself. It communicates with the OpenShift and Kubernetes API. But it's worth to mention that some of those builds architectures on works for OpenShift, and that's why it's on one of them. For Kubernetes, that was the main reason we have added support for deploy already built artifacts, right? And besides this, we also exposed on the operator the ability to user to define our own image, so they don't need to use our images at all.
I like the flexibility of it.
Yeah.
Great. So yeah, so by looking to your face, smiling and relaxed, I think you're not waiting to get the Kogito out there and everyone get using to it. And we bringing our customers and our community to this new world of cloud native, right?
Yes. Imagine that when you are going to build some application on your machine, you already have all the dependencies on your local Maven repo, right? So for S2I, we can save the Maven dependencies, or we can even use a Maven mirror that will speed up the build like 8%. But it is not the same thing that build locally, right? For example, if you are going to build the application on using containers, even if you have the Maven mirror, I don't know, it will take 2 minutes, for example, and the same application on your local machine can take 20, 30 seconds, right?
Oh, I see. Yeah, it's what is out there today, and things keep on improving. So let's see. Alex, is there any extra question you'd like to ask to Spolti, because we are at the top of the hour now?
No, I don't have anything. I just want to thank Spolti to come here and to help us to cover all this journey. That is fantastic to hear all his perspective that have been involved since the beginning.
Yes, my pleasure. Thank you guys for having me today.
Thank you, Spolti, for being here with us. It's really good, like Alex said, to hear from someone who was involved like since the early days on the cloud journey. So he saw the challenges and he lived through it, and he has the scars of it. So that's how it works. Spolti, thank you. Have a great day.
Thank you. You too. Bye.
For you who's still here with us, I will share the link for the GitHub, for the operator, for the images, everything I'll put on the subtitle. Yeah, the description of the video. Yeah, thank you, of the video. And stay in touch. Next week, we will talk about Saga patterns. Oh, the last life of the year.
That's great topic. We are talking about a lot about the cloud, microservices, and not a better topic to wrap up the year with sagas.
Ooh, I want to see that. So see you here next week, okay? Have a great day.
See you.
Bye-bye. Bye, Alex.
See you, Karina.